Okay, so welcome everybody to listen this webinar. This webinar is part of our deep dive into Sailfish OS series, and today's topic is how to contribute to Sailfish OS core. And my name is Marko Saukko, or Sage in IRC or many social media services. And I've been working as a chief engineer for Jolla for now roughly 4.5 years, and have a quite good understanding on how the platform is built and what is part of this core. At first, I would like to just give some recommendations for background knowledge. So first, to actually starting the Sailfish OS core contributions. So first is the Sailfish OS architecture. Here I have a short or simplified version of that. And as said, we are today concentrating on this Sailfish OS core part, which is actually contributed with Platform SDK. Then on top of that, we have, of course, the Sailfish OS UI and the applications and so forth. And for that, we have the application SDK. And below here, we have the hardware adaptation, which is using the hardware adaptation development kit, which is quite tightly related to the platform SDK. So now that after this, you understand more about the platform SDK, that you have a more easier path to actually start also contributing to Sailfish OS hardware adaptations and porting Sailfish OS to different devices. Of course, after architecture, you should also understand what is Linux, how to use it, how to install applications there, and so forth, as well as do things like generate SSH keys that you need to actually upload to the Git server in order to actually submit the codes from your laptop or PC to there. Then, of course, RPM packaging, which is the packaging format that we are using in Sailfish OS. Git, which is the version control system that we are using in Sailfish OS. Basically, all our code is currently located in Git trees. Then, when we are talking about core, willingness to debug build errors, that will be quite familiar to you, as the errors at times they are quite hidden in the hundreds of lines of output that is printed during the build process, and at times it's not the last line that says what is the error, but it might be somewhere in the middle, as there might be multiple threads building the bigger code blob and hiding the error a bit there. Of course, IRC, which probably is familiar to many of you already, but that's a good way to actually discuss about different things. Sailfish OS channel in Freenode, for example. And last but not least, bugzilla. So bugzilla is basically where we are tracking the work and the issues and so forth quite a bit as well. And that's also used in the release and testing processes. But going forward, so first thing before you can start contributions, you need to have accounts created. So we have a couple of accounts that might be suitable for you or something that you need, and I'll go those through next. So first thing is to actually create an account to Mere project. So basically Gitlab and bugzilla. There's a link. Unfortunately, that link currently is not functioning properly because there was a spam towards the bugzilla and the service, and because of that we had to disable the link for now. But you can get the account if you come to the Mere IRC channel in Freenode and contact either LPT or me there, and let's get your account sorted out. With that same account that you get for the bugs.mereproject.org, you can also access the git.mereproject.org, which is the location of most of the core OS platform that we are using currently. Of course, you can browse both of these also without account, so it's only needed if you are actually contributing back to there. And next thing, I'll show you the websites. So here's the homepage or landing page for the Bugzilla, for example. And here you can see here you can create new bugs, browse existing ones, or search existing bugs and so forth. And this is the landing page. Loads. So this is the landing page for the mere GitLab. So here you can actually find all the packages for the core OS at the moment. Okay. Unfortunately, because of lots of history, we have some bits and pieces of the code also located on some other services like GitHub. We are currently improving on this and trying to unify the places, and part of that work is already proceeding quite nicely. But anyway, there are some GitHub organizations listed there that you might also find interesting when working with Sailfish OS and contributing to this. Of course, in order to contribute to GitHub-based projects, you need to do a GitHub account, and there's the link below that you can do that there. So now that we have basically the accounts, the next step is to actually install the platform SDK, install the Scratchbox2 target for that. So basically the target where you are building the components for example, ARMv7 HL architecture. And regarding platform SDK, here's a picture trying to illustrate that. So basically, platform SDK is running on Linux host. You can use any Linux distribution you want, Fedora, Ubuntu, OpenSUSE, Debian, or so forth. It doesn't really matter. It should work on any of those. And while installing platform SDK, you basically just download a tarball from the internet, extract that, and then install Scratchbox2 target inside that. And from our wiki, it's quite easy to find these instructions. So here I have the Sailfish OS wiki page. And from here, I see also the same things that I explained already before. If you want to contribute apps, there's the application SDK. If you want to contribute hardware adaptations or port Sailfish OS to different devices, there's the hardware adaptation kit. And now that we are talking about the core platform, I'll click this, and we find from here, we find the different instructions, how to install the platform SDK, how to handle the source codes, how to build the packages, and so forth. Basically similar things that we are going through today. Starting from the platform SDK installation, this document here has quite a bit of detail. So if you want to understand why each thing is done and so forth, you can read the whole wiki page. But if you are in a rush, here's a quick lines that if you copy paste these one by one to your terminal, you basically get platform SDK installed. And also here you go into that platform SDK. And for that, I have here, so after typing SFOS SDK, you basically are asked your root password or your user password, and after that you are inside the platform SDK, and you can notice that from the prefix here that is added to the terminal, so that you can see that we are inside the platform SDK here. And this is basically what you achieve already with those few lines that I showed on the web page here. And basically, after typing this Sailfish OS SDK, we basically go inside this blue box that we see here. So at this point, we are already here. And now that we continue from this, so we continue installing the target, and there's a link here, installing the target, or from this platform development page, you can find also the target installation from here. The target installation, it's just a couple of commands. First one is to install the cross-compilation tools and so forth to the target for this selected architecture. Here we are using ARMv7HL, and then installing the actual target, which is just one command away. It takes a parameter, the name of the target, as well as the tarball location, which can be also a HTTP URL, for example, so it downloads it while it is there. Save time, I've already installed those myself. So going back to the terminal, and with SDK Assistant, I can list here that I have this Sailfish OS ARMv7HL target already. And now to enter to that target, I can use Scratchbox2 -t and the target name, and after that I'm basically inside this Scratchbox2 target already. And at this point, basically we are now on the green box of this chart, so we basically have the whole chain now built on the PC that we are using. Going back to this, just showing quickly that we have the platform SDK as well as the Scratchbox2 target. They are both Sailfish OS instances as themselves as well. So you can basically have all the similar commands that Sailfish OS devices have inside the platform SDK or the SP2 target. And here, for example, this SSU command, you can see here that it's an ARM version inside the SP2 target here, and if I list the status of that, it says that the device model is SDK target here. If I go outside of the SP2 target back to the platform SDK, I can do the same, and checking that here's the SSU binary, which is for Intel architecture, and if I run that, it actually says that we are in the SDK instead of the SDK target. So basically, the SSU is the same command that many are using also on the device to configure maybe some repositories and this kind of hacking or testing of Sailfish OS devices. So it's exactly the same thing within the platform SDK and the SP2 target as well. Okay, so now that we have the platform SDK as well as the Scratchbox2 target installed, the next thing is to actually get the codes that we want to use. And for that, basically, first thing is to actually find out the task that you want to work on. It might be something that you noticed before. It might be some package that you noticed that it's old, that you want to update it, or you noticed that there's some bug in some core package that you want to fix, or you were looking at the bugs.merproject.org, you noticed something that you want to fix, you noticed something in the together.jolla or something similar. And in case the issue that you start to fix doesn't exist in the bugzilla yet, you should file an issue for that, just because for getting the contribution fully integrated to up to the release level, we need to have references for releasing and testing to actually verify that what has been changed, how to test it, and so forth, and so that the release and testing people can also comment on the task and ask more questions in case needed. Okay, so after finding the package that you want to contribute to, it's time to actually download the sources. And for that, let's go first to the here. So let's say, for example, that I want to contribute or update a package called FreeType. I go here, bugzilla. Let's start, for example, filing a new bug. I go to Marko here. I find the FreeType package from the component list. And then I'm starting to update the summary. For example, update FreeType to version. And I can already see that, like this, bugzilla automatically searches for duplicates. And from the list that I see here, I already see that there's actually already existing bug. I can open that here instead of filing the new one. And here, something that if you want to start working on this, it's now already assigned to me, but you set the assignee here, and also you set the status to assigned before starting work on it, just to make sure that that there's no multiple people working on the same issue, so that we don't waste each other's time on working on the duplicate issue. Okay. So now that we have the bug here, we have the bug ID here, which we then refer on the changes that we will do. It's time to actually go and download the content. We go to our web page. From here, we search for FreeType. We found Marko FreeType package. And when we have it here, this is basically the upstream for you. So in order us to contribute, we should do a fork of this FreeType package. So we fork it for our own under our own user account. Click the fork, select our username, and then we have the fork for this package. Next thing is that you have here this URL, which is the URL for you to clone the Git tree. So let's copy that and go to the terminal. And let's clone the Git tree. And here should be noted that I wrote recursive as an option for the Git clone, simply because many of our current packages have actually submodules to upstreams and so forth, and it's nice to actually clone those as well on the first time you clone. So those also come there at the same time. Just a short moment. And now that we have after this we have the sources on our computer here. We go to the directory and we see that there's the FreeType, which is currently a submodule. We saw it here. Submodule FreeType was downloaded. And then we have the RPM directory, which actually contains the packaging. So there's a spec file and there's a changes file. And this structure that we see here with this is actually using so-called target. And regarding that, we have a target is basically a service that is executed on the releases side. It basically downloads the content from the Git tree. There are a couple of rules for that that you need to follow in order to make the process work. First is that you need to have RPM directory that contains a spec file, which we saw already in the FreeType example. There might be also a changes file in some rare cases. I'll come to that in a bit. Then, other than that, those two things, basically rest of the code can be located in a submodule, like in the FreeType example. There might be subtree, or it might be just directory and files, or something else like that. And if we go to the our wiki page, so let's go back to this platform development main page. you can see here building packages. If we open this, we actually see here packaging formats as well as target packaging structures. And here we see source code locations. So there are multiple examples of different types of packages that have been packaged, and how the submodules or so are actually done. If you want to know more about that, I'll recommend you to actually check out this wiki page. Then other thing regarding target is that the changelogs are generated from the Git commits. And basically all lines in the Git commits that start with brackets are taken from the Git commit messages to changes file. And when the target service is executed and when it's generating the changes file. The brackets, that doesn't need to be the first line. There should be always one line in a commit to make the changelog actually reflect on what has been changed. And also there should be always a bug reference if you are doing changes. However, there's the only must on the bug reference is that there should be or must be bug reference between two different tags. So on the next slide here, I have an example of MCE package. There's two commits here or tags. Basically, this commit is tagged with 1830, and this commit here on the top is tagged 1831. And between these two commits which are tagged, there's one commit here which follows this bracket syntax with the comment as well as this fixes tag on the end. And on the below here we can see actually from the package itself how that generated to the changelog file. So basically asking with RPM the changelog from the package, you can see that this file is here currently marked as a fix or changelog entry between these two tags, so 183 and 1831. Then I mentioned already here that there might be changes file as shown also in the free type example, and that's basically the reason for that is that there are so-called dumb packages. In the past there has been these packages basically contain the tarball and the spec file in the root of the Git tree. It was a bit it wasn't so nice a way of packaging things as it required storing binaries in a Git tree. So that's why target we changed to target, and currently I'm using that as our main packaging. One thing about the changes file, so it can exist, and for example here is an example. So in IW package there is a changes file, but that is not actually updated when we do updates because the package now itself has been converted to target. So now this is just for here for legacy reasons, so we know what happened before we did the conversion for target. So it is basically appended to the end of the changelog file after the target actually generates it. Regarding this, let's go to the terminal. So to do the contribution, we already had the bug created, and to speed up the thing, I already have the branch as well here. So I'll check out the branch that I had. I'll show there's one commit that I've done the modifications for this package. Let's show that package. Commit. So this also, you can see from the git commit message here that this is using target format. There's some generic information about this commit here. Then there are 3 lines that are following the format. One of them have these fixes. Then there's 2 other changes that were done at the same time, and I just wanted to comment them separately. what was done, and basically all these 3 lines will end up on the next tag when this package will be backed. If we go a bit lower, we can see there's also was changes for this spec file here. So in the RPM free type spec, we updated from 263 to 270, and that's the change here. Also, we had to rebase the patch a bit. There was some build requirement missing here, and then this is just a cleanup. Noted that the previous packager, instead of using this syntax here, he did the push and pop DO for every process here, which is it works, but it's not mandatory. You can use this syntax here, so I fixed that at the same time. So now that we have the changes, now that we have the tools that are needed for building, we can actually build this package. So if we check the RPM directory, we notice that there's one patch. Packages that have patches in the RPM directories and in the spec file, before you build a package for testing, you should apply those patches. For that, you can use mp2 apply, which basically reads the spec file and applies the patches from the spec file to the location where the build happens. So basically, we type directory. And after that's done, we can build the package. So we can use the mp2 command here. And for that type of build option, and then it actually starts building the package. While the mp2 builds, it actually downloads also the build requirements. So the spec file here, it also has these build requirements. So if there's build requirements missing from your SP2 environment, for example, it will automatically download those while doing this build process. Of course, it doesn't re-download them every time, but on the first time, if it knows that it's missing, then it does the download. While this builds, I'll show you the web page a bit. So in this web page, the build web page, there's also this dump package format mentioned. So some packages are not using this target format. There's multiple reasons for it. Maybe there's no Git upstream at the moment, or the package for some other reason couldn't be using Git job module or so. So some of those are still in dump package format, and for those, this mp2 build command doesn't work. So you can actually use sp2 to actually go inside the Scratchbox2 environment and then calling the RPM build to actually build the spec file manually instead of mp2. Okay. Now let's go back to the terminal. Finished. Okay, it's still building, but basically this is what I mentioned in the start. So there might be a lot of output coming from the build, and it might be that, for example, here this build is made with 4 threads. So while this builds, and if one of those threads fail, other 3 continue until they fail as well. For example, missing file from the other thread that failed. So the build error might be somewhere in between of this output. Now that the build is completed, mp2 results for these RPM packages. Here you can see free type and free type devel package that was generated from this. And when we have that, then it's actually time to verify the package. So after building a package, things that you need to do is verify the package, create a pull request to the upstream Git tree, and then wait for the reviews. So basically what we now have done is to build the package. The verification should be something that is done for actual device or emulator so that you can actually verify that everything builds. Also, if there are reverse dependencies, so some packages depending on this package, you should also rebuild those against it. But that's out of the scope of this presentation for now. So the simple way that we are now doing this is just verifying the installation of these packages, and for that I'm using this Scratchbox2 environment that we have. So currently on SP2 target, we have we can ask that what's the free type package version there. So currently this 263 is installed there. We can install this package to the environment with RPM command. This just give the SP2 command a bit more access rights to actually do this operation. And now this is one of the things that I told about reverse dependencies. So currently in the SP2 environment, there's another package called FreeTypeDevel that is depending on the FreeType exact version of that package. This time, as the same FreeTypeDevel package was built within the same build, we can just add that to the installation and then have that package installed. And now it installed both of the packages to our SP2 environment. And we can check again, and on our SP2 target now there's a FreeType 270 installed on the same target where the 1263 was previously installed. So this is just an installation test. It doesn't really verify that everything works fine, so you should install it to actual device or emulator and inspect it further if it's okay. But of course, I should be remembered that when you are touching this kind of core packages, it might easily brick your device or make it unbootable, so make sure that you don't cause problems with your device. And that's why checking, for example, the emulator that is provided with the Sailfish OS application SDK could be a good target for installing this. After this, it's time to actually do the pull request. So we have the mere branch here. We push that to this Git tree. Now it says all done, as I had it there already. But basically this is the way that you push it to the mere Git tree. And then after that you go to the web page. Here, let's go to this FreeType. So we are in this in our user account under the FreeType under our user account, and here we can select, for example, the branches. We can see this mere 1697 branch here, and we can see also the merge request button here. And while clicking this, it will actually show you the merge request in more details. It says from which repository and which branch it does the merge request, and to which repository and which branch. It automatically picks up the title, which is the first line of the commit message, and then the description from the rest of the lines there. And while doing this merge request, you could already here assign the merge request to certain people. But if you don't know who you should assign it to, just attach the merge request link to the bug that you were fixing, and maybe paste it also in a, for example, excuse me, in the IRC channel, and then from the IRC channel the people can pick it up, or maintainer will pick it up from the Git. And when everything is set, you click the submit merge request here. And after that's done, we go to the actual free type package. So we find the mere core package and the free type here. And from here, we can see the merge requests, and we can there actually check what kind of merge request there has been. And after that, we can review the changes, we can comment on the changes. So for example, in this case, we can see here what was changed, all the same things. You can also comment on here. For example, here's a comment for that line. I forgot to rename this comment or rename the comment as I renamed the patch anyway here. So the comment is actually referring to the old patch file name. So that should be changed. And after you have done your review comments, if you don't see anything wrong in the discussion, you can say LGTM, so looks good to me, give thumbs up, or yeah, so thumbs up written like this, so writes this symbol. Like this. And basically now we are ready for this. So now the thing is to wait for the review comments on this particular merge request. In addition to the way that I just showed how to create the merge request, there's also a way to actually contribute with the web browser. So you can actually open the GitLab web page and do the similar process from there, which I'll show next. So let's, for example, go to the main groups here, select mere core. From there, let's say that we want to contribute to lipstick package. From the lipstick package, then we do the same as for the other free type package I showed. So fork it for your name so that you can actually do the modifications. Then after doing that, you can do, for example, new branch here. Put a name for the branch, for example, webinar example. And after that, you can search for the file that you want to contribute to. Let's say want to add a Android notifications for some Android app. So we browse to the Android notification priorities file. Here is the file, and we can click edit. Go to the end of the file here and add our changes to this file. Let's say that we have an app called webinar example. So here's the change that we did. Then the commit message. So let's say that we add webinar. Then of course we need to remember to add the changelog for this. So do this, and then for example fixes where XYZ, for example. Then we can commit the changes, and after doing that, takes a moment. After doing that, it already says here that if you want to do merge request, let's click there. And now we are on the same situation. It says that from my lipstick fork, from this branch to mere core lipstick master, I can fill in these details here and to see the changes, for example, from here that I did. So I did this change, and then I can submit the merge request. So also, this is one way that you can do this kind of small configuration or setting thing change that doesn't require compiling and verifying the code, for example. So this kind of small notification priorities and this kind of thing might be something that can be done quite easily from here. Then one thing that has been asked quite many times, there's okay, sorry for that. So basically, looking for the oldest package is something that has been asked quite many times. So what is the oldest package? Where should I start contributing? So we have multiple hundreds of packages in the core, and not all of them are the latest and greatest version. So there's a good chance that you can find from that list some packages that you could contribute to by just looking at the age. So let me show you, for example, from the terminal. So I have here the same script and the output actually listed here. So this is listing the some of the packages and when they were last modified. Of course, it doesn't say when was the version of this package done in upstream. It says okay, there seems to be an issue with the stream. Just a moment. And we are back. So basically, this is a list of packages that you could contribute to, for example, in Sailfish OS. Okay, so that was my presentation. Got any questions in mind? Did I miss something important or something else that you would like to know? So we have some sailors here helping out on the chat. So and there's a small 10-20 second delay, so I might not see everything or respond instantly. So if you have any questions, please free to ask them there, and let's get those So any questions? This was quite like a surface thing for the platform SDK, so there's quite a lot of other things as well that you could do with it. And many of the people probably have already inspected, for example, the hardware adaptation development kit that is quite heavily using the platform SDK. And also should be noted that the application SDK also has platform SDK inside it. So even if you are using the application SDK, you there have a platform SDK also on the same installation. That's a topic for some other time. There's a question regarding 64-bit support. So how to build mere SDK or so for 64-bit architecture. That's currently something that we are working on. So if you have, for example, followed the some commits in the mere core, we are currently working on this 64-bit support. So there has been quite a many commits. Let's see if we can show some of them here. Go to core, and I think these are somewhat in order of I know for a fact that in, for example, libtalloc, there should be a commit just done for 64-bit. So there was probably 20 or 30 packages that we had to touch while doing this 64-bit support or fixing things for 64-bit ARM architecture. So that's some of these enablers will be already in a next release after 2.05, but the architecture itself is not fully enabled yet, as there are still quite a bit of things to do, but proceeding quite nicely. Then there's another question coming through another channel regarding can I access with SSH the SDK? So for that, I already mentioned that within the application SDK, there's the emulator and the virtual machine instance called build engine, I think. The build engine is basically essentially the same thing as running in VirtualBox, the platform SDK. So you should be able to actually do similar things for this build engine for the application SDK. Currently, I don't have a detailed guidance how to do that, but I can check if we can add somewhere how you can connect via SSH to, for example, the application SDK build engine and use it on the similar ways that mentioned here for the platform SDK. Then next question is about OSC. So some of you probably have used OBS and OSC to actually build packages. Basically, that's a one way how things can be done. Although for building anything with OSC that requires that you have a repository in OBS and also building packages there, the good thing about that is that in OBS you can also automatically build the reverse dependencies. But the bad thing about that is that it's not so easy thing to set up, and maybe not something for this webinar. Probably do another webinar regarding how to build the reverse dependencies. But from the web page that I showed, there was the on the wiki page that I showed here in the core platform, and then in the building a package. Basically, the thing that used to need the OSC was this dump package building. So from the top here, dump packages. Usually people are using for this kind of packages, using to build them through OSC, but you can actually do that with RPM build as well. So there's no need for OSC as such, except if you want to automatically build reverse dependencies. But currently there's no actual tutorial for how to do that. Then for one question is how would it be easy to port a Makefile project into this framework. Currently each package is built a bit different way, so I don't know if this is what the question there was about, but each package has a bit different ways of building. Some are using make, some are using CMake or QMake. So we haven't really gone further than this, as the build recipe is basically in the spec file. So if we inspect the spec file of this, for example, this free type spec file, then basically the build process, for example, for this package is currently listed here. So these 5 lines here are actually doing the build for this particular package. Anything else? Any other questions? Then there's a question regarding upstream projects, especially regarding Conman. There's a person who's been waiting for getting a patch to Conman, getting it accepted to the upstream. I'm not really the right person to comment how long it takes to get these kind of things, but we are sending our patches quite a bit to upstream, and some of those are accepted. And in case the patch is not accepted for some reason or another, we discuss about it with the upstream, or then we have to start maintaining our own patch set on top of the upstream that we do for a couple of packages. Well, the build system that we are currently using, so we are utilizing the so for this we are utilizing quite a bit Scratchbox2 and just GH root, and it's basically something that has been developed within this community for quite a while for the Mayor and other projects. So I don't think this kind of build thing is currently used on any other project at the moment. Okay. I don't see any other questions anymore. Have I missed something or? Okay, so there was actually a link that so there's one question about is it possible to contribute new packets somehow and expand the base repository? Yes, so that's also possible. Although it should be remembered that we are trying to keep the core of the OS relatively small in order us to it to be maintainable. So that's why there's not full set of packages like in Fedora or so forth, because that would end up easily for thousands of packages. So we are thinking quite carefully what we actually build as part of the OS. But if there's a good reason, there's no reason for installing a new or making one new package available. Of course, that can be considered, and I would recommend you to come to IRC or start a thread in for example, Together or Mayor project Bugzilla about including a new package to the core OS. And fellow sailors just shared me the here's a web page. So there's actually a web page in the already about how to use the SDK, how to SSH into that SDK and use that application SDK build machine as a similar SP2 target. So this web page here should actually have some more information about that. I haven't read it myself at the moment, so, but this should help. There's one more question about how to verify a package oneself before uploading it. I would recommend for that to actually check this application SDK emulator, installing it there, or so forth, and then using that for that. So then you can be sure that if that boots up, then you can more safely do contribution that as well. But of course, you can do always like install it on a device, but make sure that you don't break it. But there's quite a lot of these community ports that are quite freely available for different devices for Sailfish OS. So those are quite handy also for this kind of work. Easily replace the whole file system, for example, for the device, and then start again if something failed miserably on the installation. Okay, I think we are good here. I don't see more questions anymore. Or let me check my colleagues a bit. So one more question regarding the 64-bit, asking is there instructions how to make that for ARM. Currently there's no instructions. There's some discussions in the Sailfish OS porters channel for the hardware adaptations when there's some porting effort ongoing for the 64-bit builds. But I don't think there's currently instructions outside that IRC channel. Okay, I think that was all the questions. So I would now propose that if there's more questions, feel free to ping me in IRC and continue the discussion there. And thanks for attending and for the questions and so forth. So thank you.